Hi everyone and welcome back to the channel. I want to ask you something. Have you ever wrapped a balloon on your hair and suddenly your hair stands up? Or maybe the balloon sticks to the wall. But here is the real question. How can something push or pull without even touching? Today, we are going to uncover the invisible force that controls that mystery. And I assure you that by the end of this lesson, you will understand something powerful. That there are invisible forces around you right now, even as you watch this video. But don't be scared. This is electric forces and electric fields. Let's begin. So what then is an electric charge? An electric charge is a property of matter. What it basically means is that we know matter is anything that has mass and can occupy space. And within matter, we have a tiny particle called an atom. So we have an atom within a matter or within matter. And then inside the atomic structure, we have something we call protons. We have electrons. And then we have what we call neutrons. But by the purpose or for the purpose of our studies today, we are going to talk about protons and what? Electrons. Now we know protons are positively charged particles, whilst electrons are negatively what? Charged particles. These are the two charges that we have. And if something has electric charge, it means it can experience what we call electric force. Now here is where it gets interesting. That there are only two types of electric charge in the entire universe. That is what? The positive and the negative charge that you can see here. These are the only two charges that we have. Positive and what? Negative charges. And nothing else. Everything in electricity comes from just these two types. So you're going to think about that. Let that sink in. Two simple types of charges, but they control lightning, they control electronics, they control electricity, even they control every tiny particles on earth. And these charges, they cause objects to experience what we call electric forces. And they determine how objects interact with each other. So let's dive in to see how these objects interact. All right. Now here is the rule you must never forget. That light charges, they repel. Meaning light charges what? They push away, as you can see the arrow. This is positive and positive charge. They are like, so they push away. They repel. And then if we have negative and negative charges also joining together, they also what? Repel. But when it comes to positive and negative charges, they draw closer to each other, meaning they attract. And this pushing and pulling is what we call electric what? Force. It's what we call what? Electric force. So the pushing and pulling of these charges is what we call what? Electric force. And here is what makes it powerful. They do not need to touch. They can act from distance. That is why we call it a non-contact force, meaning they don't need any interaction. They don't need to come closer, touch each other before you can see this force executing or exerting its influence. Just like how gravity pulls you to the earth without touching you, so electric forces can also push or pull without contact. They are invisible, but they are very real. All right. So let's look at electric forces. So how they do. We are saying that electric force is simply the push or the pull between charged objects. So two objects that are charged, meaning they are positive and negatively charged, or positive and positively charged, the forces, the push and that pull is what we call electric force. And if charges are close together, the force is what? Even stronger, as you can see here. These charges here, they are close together, and we can see as they are close, it tells us that they have a strong force exerting here, meaning the pulling and the pushing is very high. And since it is here we have positive and here we have negative, it means the attraction is very high. And here we have positive, we have negative, but they are quite distant away from each other. It tells you that the forces or the force that exists between them is very weak. So distance matters when it comes to determine an electric force. The closer the charges, the stronger what? The forces. And the farther apart they are, the weaker the forces. And this means that electric forces what depends on distance for us to experience whether strong force or weak force. And this is the key idea in physics. And for grade 7, remember that the closer equals stronger force and farther equals what? Weaker force. All right. So let's move to look at what an electric field is all about. So imagine you have a charged object in your hand. Even if nothing is touching it, it creates something around you. You normally hear of mobile phone radiation. That when you place a mobile phone right by your ear, it emits some radiation. The question, have you ever seen it? But is the effect real? Yes, of course. The radiation effect is real. That is exactly what happens to electricity as well. So in electric field, there is something powerful. This is an invisible region you cannot see. So we say that an electric field is the area around a charged object where its forces can be felt. We know that our mobile phones have these positive and negative charges, and this radiation effect is emitted. But the point is that we cannot see it with our naked eyes. And the area that these charges applies or work, that is the field, that is the region around where this charged object works. And that is where we can feel its forces very high. So we encourage that when you are making call, you should either use any headset or earphone so that it can distance you from the phone, so you will not feel the effect of radiation highly. That is exactly. And these regions are invisible. And that invisible region is what we call the electric field. So it is the area around a charged object. And this exists around any charged object. Around any charged object, this region is created. If another charge enters that space, it immediately feels a push or a pull. All right, even without touching it. Think of it like this. The electric field is like the influence zone of a charge. It is where the charge has power. You cannot see it, but you can see its effect. And in science, when something has measurable effect, we know it is real. And these effects are real everywhere. So as you can see in the image here, these are the invisible region around a charged object. Just that we can't see them with our naked eyes, but we can measure their effects. All right. So let's look at field lines. You know, scientists draw electric fields using something we call field lines. So the field line, what it does is that it shows the direction where the charges are going. It tells us where a positive charge will move to, and these field lines always move. So we are saying that from any positive charges, they move towards negative charges. So positive charges will move away, whilst negative charges they move away towards the negative charges. So as you can see, that is the direction it is moving, and then it will move towards what? The negative charges. So when you rub a balloon on your hair, what happened is that the hair lost electrons to the balloon, making the hair becomes what? A positively charged particles. So that region has a positively charged, and it move or lose its electrons to the balloon to make the balloon also negatively charged. That is why when you use the balloon to touch the wall, it could stick to the wall. And as a result, your hair also stands up because it gets electrons out. It has positive what? Charge now. All right. So if two positive charges are near each other, the lines push away from both, as we have established earlier, that if there are two positive charges, they what? They move away, they push, they repel. I hope that is clear. And if a positive and a negative charges are near each other, the lines connect from positive to negative. So the positive will move and lose or give out towards the region of what? Negative. And these drawings help us to see the invisible lines or charges as they move and the direction at which they move. So anytime you are seeing a cell or a battery, you realize it has positive and negative charges, then you should know the direction at which these charges what moves. And this direction is what we are referring to as what? The field lines. They move from a positive charge towards what? A negative charge. I hope that is clear. All right. So these are the two charges we are talking about. That opposite charges, they attract what? Each other. I hope that is clear. So if the field lines push away from each other, if one is positive and one is negative, they what? They attract, as you can see here. If one is positive and one is negative, they what? They attract. The field lines go from the positive charge direction towards the negative charge. As you can see, the direction moving here. It's moving away, and it is going to the negative charge. They are all going to the negative charge. So this is what we call the electric field lines. And these patterns, they shows what? Attraction. As you can see, this is how scientists understand what we call electric interactions, how electric fields or how these two charges interact through a certain patterns, through forces, and through the field. All right. So let's look at some real life examples that we can see. If you haven't watched the video on static electricity, I will encourage you to go back and watch that. So let's bring this to a real life. In static electricity, as you can see in the image, we see a young man holding what? A balloon, rubbing it on an object. So when you do that, what happens is that the balloon becomes negatively charged after the object giving out electrons to the balloon. And we know electrons are negatively charged. And once the object retains a positive charge, hence making the balloons becomes what? Charged particles. And anytime we use that balloon closer to a wall, now what happens is that they attract or they get attached to each other. All right. So that is basically what happened. But remember, these forces are what? Invisible, but they are powerful. And if you have probably done this experiment at home before without even realizing it, then you were demonstrating what we call physics. Most of us probably might have done this, but we don't know what it is. Remember, science is what? Everywhere. All right. So we're going to pause here, and then you're going to think about this in this review questions. Answer these questions. Check your knowledge on what we have studied so far, and then come back and then check if your answers are correct. All right. Question number 1. It says, what are the two types of what electric charges? So you can pause the video, answer these questions, come back to the video, and then confirm if your answers are correct. The correct answer is that positive and negative charge. The two types of electric charges that we have are positive and negatively charged particles. Then the second question, what happens when like charges what meet? Of course, when the poles are the same, positive and positive, negative and negative, they do what we call they repel or they push away. And finally, what happens to force when distance increases? When the distance is high, we know that the force becomes what? Weaker. The force will no longer be stronger as when they are close to each other. So brethren, this is what we have learned so far. Today, we learn what we call electric charges. And we learn that electric charge is a property of matter. There are two types of charges. We have the positive and negative charges. And we talk about like charges repel, unlike charges what attracting. And then we talk about electric force being a non-contact force. We don't need to come together or touch each other before you can see its effect. They are real. They are invisible. And then we also talk about an electric field being an invisible region where the forces can be what? Felt. You cannot see electric fields, but you can see what their effects. And then we also talk about what scientists does. They explain the invisible. And I assure you that in our next lesson, we will explore magnetic forces and magnetic fields and compare them to electrical forces. Don't be confused. This will be made clear and simple. So make sure you subscribe to the channel, turn on the notification bell, and stay ready for more videos. Because physics is not difficult. It is powerful. And now you understand the invisible forces around you. Until then, see you in our next video. Bye-bye.